Today's lesson is for 3.4 and 3.5. We're going to solve inequalities using all operations. The first thing we're going to look at is how do we solve inequalities with addition and subtraction. So the first thing I need you to do is open up a dual screen for your notebooks. So we're going to do some definitions here. So we have, first of all, an inequality is an equation with an inequality between two expressions. So an inequality is basically one of these little symbols here. I'm sure you're very familiar with right there that has that little greater than, less than, or equal. And when we talk about the solution to an inequality, we're talking about any number that produces a true statement. So what we did in the last unit was if we had x plus 3 equals 5, well, we want to know that is 2 a solution to that equation. So what we would do is plug in the 2 there. So yes, 2 plus 3 equals 5, so 2 is a solution. And that's the same thing we're going to do when we talk about inequalities. We're just going to plug in and see if it satisfies the condition. And this should be a review, but the things we want to think about today are the terms greater than, which is an arrow pointing this way, less than, greater than or equal to. Now that means we have the little line underneath it, which is half of an equal sign, or less than and equal to. Now if we were to apply that to a graph, let's take a look at the first one. We'll go right down the list quickly. This says x is less than 3. So 3 becomes our point number. So you can see we're just going to put a circle around our point number. So all these numbers, x is less than 3, satisfy this condition. Is 0 less than 3? Yes. Is negative 2 less than 3? Yes. 2 less than 3? Yes. So we have a solid line because all these numbers and all the little numbers in here also are less than 3. Is 5 less than 3? Absolutely not. So that is not included. Do the same thing for the next one. Y greater than 2. We put a circle around the 2 and go this way. Now let's go down to the next one and see where the little difference is. Z less than or equal to 4. So here you see I've drawn a circle on the 4 and all the numbers less than 4 are included in that set. But what number is also included is the 4. So you can see on this graph that the 4 is colored in. Whereas above here, when we were looking at y is greater than 2, there's an empty circle on the 2 because 2 is not included in that solution set. So same thing goes for right here. Here's the difference between that one and this one is x is greater than or equal to 2. So you can see this one is colored in and all the numbers here. So the difference between this one here and this one here is only the equal sign because the 2 is colored in here and not colored in here. So one way to know whether to color it in or not is if the answer is included, we color in the circle. If it is not included, it's open. And here's an example on the graph. So we're saying x is less than 3. So is 3 a solution? No. So because you have a 0 there, a no, it's open. What we're going to be asked to do in this section is to solve and graph inequalities. So if we look at our first one here, this is m plus 5 is greater than or equal to 10. So what we want to do is treat this just like a regular equation. So if I just had m plus 5 equals 10, what would I do? Well, I'd subtract 5 from both sides and m would be equal to 5. So that's the same thing we're going to do here. We're going to subtract 5 from both sides and m is now going to be greater than or equal to 5. And so here we've got our 5 as our point number. We're going to color it in and all these numbers greater than 5 are part of our solution. And our second example uses some negative numbers. The integers are not going away. Here we've got x written this way, x minus 12. We want to add 12 to both sides. So we add 12 here and add 12 here. Negative 10 plus 12 is a positive 2. So one thing we want to talk about right now is you can see they've got the solution written as this way, where the arrow 2 points at the x. It's greater than the x. What we want to try to do is write it with the variable on the left-hand side of the equation like they've done here. So what we're going to do is flip it. So we're going to make it x is less than 2. You can see here the arrow points at the 2 or at the x, and it also points at the x here. So even though it's on this side of the inequality now, we can see that the arrow still points at the x. This will help us with graphing. Now we can put a circle on our point number and look at any number on this way, the arrow goes toward this direction. I'd like you to try the examples that I have pushed to your form. And this is the final part of today's lesson. We're going to use multiplication and division in this part. So how do you divide and multiply when you have an inequality? What we do is first use inverse operations. So again, if there's an addition or subtraction, we're going to get rid of that first. Here's the problem. Once you are left with just a negative or positive, you need to write this rule down. If you are multiplying or dividing by a negative number, you have to change the direction of the inequality. That sounds like a lot of words, and we're going to clarify that for you right now. I have a very simple problem on the board, or a statement right now. 2 is less than 5. Everybody knows that. But let's just say we multiplied both sides of this equation by negative 3. Negative 3 times 2 is negative 6. Negative 3 times 5 is negative 15. But now look at this. The arrow is pointing the same direction as it did up here, but it's not correct because everybody knows that negative 6 is greater than negative 15. It's closer to 0. It's farther right on the number line. So it is greater. So the direction of the arrow is not facing the correct way. So when we divide or multiply by a negative number, you have to change the direction of the sign. Our first example here, look, we've got m divided by negative 3 is greater than 3. Well, we know. What are we doing on this side? Well, we're dividing by negative 3. So the opposite of dividing by negative 3 is to multiply by negative 3. And if we do that, we're going to multiply by negative 3. So we're going to be m on this side and negative 9 on this side. But based on what we just said, what do we have to do? Change the direction of the sign, and that will make that equation correct. So I'm going to look at 2 quick, and then I'm going to turn you loose on your own problems. Let's look at number 1 right here. N is divided by 6 is greater than 7. So since we're dividing by 6, we're going to multiply by 6. So it's going to be n is greater than 42. No problems. There's no negatives, so we don't change the sign. All right, over in number 4 here, take a look at this. We have negative 7s is less than or equal to 14. Since I'm multiplying by negative 7, I'm going to divide by negative 7. And since I'm dividing by negative 7, s is going to be negative 2, but we have to change the direction of the sign to make it greater than or equal to negative 2. All right, go finish your problems, and we'll talk with any questions.